So what do you notice or wonder about these two graphs? When do they end? Thanks, guys. Okay, why don't they have arrows at the end, maybe? What's the difference between these two?
One's
One is looks like a parabola, but look at the, it looks like a W, right? Yeah. And then this guy looks like, this guy is a, what kind of function? Cubic function, right? Okay, cool. All right, again, you're calling this end behavior. Okay, so one member of your group should make a copy of the Google Slides and then share it with me. Okay, so we're gonna explore. So if you want to do the QR code on that, it's the fact that I have too much storage. What? So you're taking a second. You got odd degree on the right-hand side, even degree on the left, positive in the top row, negative in the bottom. Take a second, go ahead and write that one down. Okay, again, it's gonna be even on the left side, odd is on the right, positive and negative leading coefficient. Okay, I'm gonna start talking about this. I'm gonna make your life a little bit easier on writing all this stuff out. So instead of writing all these words, you can actually write this with arrows. So if you want to write it once, that's okay. But I'm going to show you a shortcut in just a second. So if I have an even degree positive leading coefficient, that means examples of this would be like x squared or x to the fourth plus 4x squared plus 4 or x to the sixth, 2x squared, blah, blah, blah. Okay, they're always going to look like this, roughly. So when I write this out, it's going to be as x approaches positive infinity, so that's what that arrow is, y is also going to approach positive infinity. As x approaches negative infinity, y is going to approach positive infinity. I just did. I'll give you a second. Okay, now if we have negative leading coefficient, that's going to be something like negative x squared, negative x to the fourth, blah, 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 blah. Negative x to the sixth. So this is going to look like downward frowny face. And that's kind of hard to see on that board. It's the downwards. Like this, flip it upside down. Okay. And as x approaches, I could do this white maybe, and that'll show up better. As x approaches positive infinity, y is approaching negative infinity. As I die. I'm so sorry. I took on my own spit. As x approaches negative infinity, y is also approaching negative infinity. Again, facing downward. All right. So if we have odd degree and we have a positive leading coefficient, that's going to be examples like x to the third, 5x to the fifth, that kind of stuff. I'm just making up stuff. Okay. So with that being said, these are always going to look roughly like this. Now there may be some more squigglies in between, but all we're really focused on is the end of what the function is. Okay. So as x approaches positive infinity, y is also approaching positive infinity. And then as x approaches negative infinity, y approaches negative infinity. Okay, so what this all means is in behavior is as if you were standing at 0, 0. This is you. Best stick figure ever. Okay. If you're so much taller than that. Yeah, I feel that. Okay. If we look to the right, what's happening to our y values? They're going up. That's positive infinity. As we look to the left, what's happening to our y values? They're going down. They're yelling timber. Okay. So that's a negative infinity. Okay, that's what in behavior is. Where does the function end up? All right, let's talk. Okay, so if I have a negative leading coefficient, that's going to be stuff like negative x to the fifth, negative x to the whatever, okay? And that's going to be the opposite direction. So as x approaches positive infinity, y is now going to be negative infinity. As x approaches negative infinity, y is approaching positive infinity, okay? We always talk about the right, then the left. I don't know. That's just kind of how, you know, like when people say like you're going to cross the street, they tell you to look right, left, then right again. No, they do the other way. They do left, right, left, right?
Yeah, left, right, left.
The cars come from the left.
I don't even look before you cross the street. Okay, so writing the end behavior for these four. Okay, so what I want you to do is go ahead and write number one down. So we are writing the end behavior for number one. Okay, tell me, is number one an even degree or an odd degree?
Even degree.
Even degree. Is the leading coefficient positive or negative? Okay, so we have a negative even polynomial, right? Okay, so my end behavior is going to be as x approaches positive infinity, what's happening to my y? Okay, and then as x approaches negative infinity, what's happening to my y? Fantastic. Can you try? How do we find it? Look at the exponent. Exponent is even. This one is, okay, and then this one is, and then this one is, try again. Odd. It's got a 1. Okay, take a moment and then use your chart to write out the end behavior. I want you to try these.
No side.
Man.
So bad.
All right, so let's talk about this next one. Is it positive or negative? Okay, and is it odd or even? Okay, now looking at your chart, as x approaches positive infinity, what's happening to y? It goes to positive infinity. As x approaches negative infinity, what's happening to my y? It's positive odd. This is going to be negative infinity. Remember, this looks like this. So looking to the left, it's going down. Looking to the right, it's going up. Yeah.
Like memorize it?
I personally would, just because it makes it a little bit easier to do. But you can also be like, draw the graph and then be like, all right, I'm standing at 0, 0. What's happening as I look to the right? What's happening if I look to the left? You can do it that way. Yes, you did. You learned in behavior a while ago. You just haven't seen it in a while. All right, on the next one, you have positive even, right? So as x approaches positive infinity, what's happening to y? It's going to positive infinity. As x approaches negative infinity, what's happening to y? Nah, it's positive. So evens are really easy because they both are facing the same way. So if you figure out positive even, they're both facing up. If you see negative even, they're both facing down. Does that make sense? Okay, on the last one, we have negative odd. Be like that sometimes. As x approaches positive infinity, what's happening to my y? Okay, and then as x approaches negative infinity, it's going to positive infinity. So this guy is going like that. Okay, you're gonna get some practice with this. With that being said, these matching definitely are going to be helpful because look at how these guys are written. You got them in the x approaches stuff, and then you got it written in words. Okay, really quick, if we say as x gets larger and larger in either the positive or negative direction, that's talking about as x approaches positive infinity, as x approaches negative infinity. Both of these are going up. That's what this is saying. Okay. Yeah. Okay. So I would like for you to get to slide Get to slide 10 and we should be good. Go ahead and take a little bit of time. You're working on that. Really quick. On slide 5, is the degree odd or even? How do you know, Ellen? They're both facing up, right?
Yeah.
If they're both facing in the same direction, you know that it's going to be even. Okay, so it's even. Is it positive or negative? Positive, it's facing upwards. Looking at slide number 6, is this polynomial odd or even? Odd. And is it positive or negative? It's positive. Okay, what's the degree of this one? Okay, and what is the end behavior?
As X approaches, negative infinity, it approaches infinity. I approaches negative.
Good. Sorry. So the way that you draw an arrow is you do the minus sign and then you do shift period. So as X is approaching negative infinity, what's happening to Y? Going to positive infinity.
Yeah.
Okay. All right. So I do want to jump back and just kind of go over one of these problems because I know you were having some trouble yesterday with this stuff. Yeah, there we go. Okay, so you should have picked up this worksheet. Okay, when you find, right, when you find this, you can either use synthetic division, you can do the remainder theorem, it's completely up to you. I'm going to do synthetic division. I'm going to switch the sign of this, put him in jail, write out the coefficient. Bring down my first term, multiply, add, multiply, add, multiply, add. So this gives me x squared minus 4x plus 4. Now, our instructions said to factor completely. Okay, so can I break this down more? Well, when I do my big X and I say a times c, that's going to give me 4. B is negative 4. What two numbers can I multiply together to get me positive 4, but add together to get me negative 4? Negative 2 and negative 2. So this can be rewritten out as x minus 2 squared. Now we had that x plus 6 at the beginning, so we can just write that out beside it. Where are our zeros going to be based off of that equation?
Negative 2, positive 2.
Okay, positive 2 and negative 6. 5, 6. Okay, now what kind of polynomial is this, or what degree polynomial is this? It's a positive odd, so we know that in behavior is going to be down on the left hand side, up on the right hand side. So if this is a third degree polynomial, then it's going to look like this. Because it's a third degree polynomial that's positive. Yep. So you have to synthetically divide, and then we factored. When we had this x minus 2, then we solved for it. Yep. So our zeros are at negative 6 and 2. What I want you to notice on this one, and we haven't talked about this yet, but right here, there's a bounce, and that's because there's an exponent of 2. We're going to talk more about that a little bit later. I keep saying that, but we are going to have that conversation soon. Okay. The second one. What do you mean? Oh, on the second problem, it says like f of what? Okay, that's basically like if in first problem, we said f of -6. We took -6. You're just gonna take -14 and do synthetic division. Yeah.